Hey everyone, this is Muhammad Nadeem and welcome to my YouTube channel. Today in this video we will discuss that what is wire wound variable resistor. So this is actually a device used in a circuit in order to control the current and the potential inside that circuit. So we will discuss this in more detail here in this video. So let's say we have a problem statement, and that problem statement is this. Let's consider we have an LED light. So let's say this is the LED light, and this light required about 3 volt voltage, and we have a battery here, and we have 10 volt battery. So no such small voltage battery is available in the market. So therefore we have this 10 volt battery. This is positive terminal of the battery, this is negative terminal of the battery, and we have this we have a device here, in this case LED, and which need 3 volt battery and 3 volt voltage, and in the voltage of this battery is I'm going to mention here is about 10 volt. So here we have 10 volt and this LED required 3 volt battery. Then how we will solve this problem? So for that we will have to introduce some device here in order to control this voltage. So we will discuss all about here. Now similarly we use the fan, okay, in our home, and we want this to be slow, and for that we use this dimmer. So what is happening inside this dimmer in order to increase the speed or increase or decrease the speed of this fan? So in this video we will discuss that. A device must be present here to control this current through this and also voltage to this device. So here we have the concept of the current divider and also the potential divider. So for that we will use the device, and that device is much simple as look like here. So here that device is actually consist of this shape. So here we have this white color is actually a pipe, the insulator pipe. This is actually the pipe. So here we have, this is the pipe, and this pipe is wrapped or wound by a large wire. So here the wire which is which have the black color, and that black colored wire is wrapped around this pipe. So here we have this thing which is called the sliding contact. This is actually we have the sliding contact. As the name indicated, this thing will be slide, and this what we can say conductor, and will contact into that wire which is wrapped around the pipe. So this simple device here I discuss, this simple device is called Rheostat. This simple device is called Rheostat. Rheostat is that simple device, and we will control the flow of the current, mean the flow of the charges, mean we will control the current in a circuit and the potential in a circuit through this device which is called Rheostat. So how to control the current and voltage through this device? So let's discuss that in more detail in the form of simulation. So here we have the simulation. In this simulation you see here, this is that device which is called Rheostat, and I discussed this before. Here we have this white color is actually a pipe, and this black color wire is wrapped around that pipe, and we have this sliding contact, and this device is called Rheostat. So here we have the battery, and the one side of the battery is positive charge and the other side of the battery have negative charge, and let's say we have this a positive charge. So let's say we have this a negative charge. So so let's say we have this side of the battery is a negative potential. So the one side of this battery is connected to the here to this conductor. I'm going to mention the flow of charges here. So this is actually that, and we have this potentiometer, and the one side of this battery is connected to the this contact, and the other side of the battery is connected to the one side of this wire. So here we have the wound wire, so the one side of the wire is present here, and the negative terminal, the positive terminal of the battery is connected to the one side of the wire, and the other terminal of the battery, negative terminal of the battery, the negative terminal of the battery is connected to the sliding contact. And now we will focus here. Here the intensity of the light from this bulb will be more if I'm going toward this. So here the intensity will be more, and if I move this sliding contact away, then that intensity is decreasing. So here this intensity is decreasing. In other words, we can say that the current is decreasing. So here the intensity is decreasing, mean the current is decreasing. If I slide this contact toward this position, then this intensity, mean this the current passed through this resistor is increased, and if I move this away from this here, this intensity is decreased, mean the current flow through this resistor is decreased. So what is happening here to increase or decrease the current through the resistor? So here we will use we will use the formula. So from the Ohm law, according to Ohm law, V is equal to IR. So from here we are interested in the current. So current is equal to V by R. So here we want to increase or decrease this current. In order to increase or decrease this current here depend on two parameters. So the first parameter here is the variable, and this current is directly proportional to, the first parameter is actually the voltage, and this current is directly proportional to that voltage. And similarly this current is inversely proportional to this resistance, and here is our problem is that we will have to increase the current, increase or decrease the current to this the resistor. So the same in order to increase or decrease the current, we will have to change the voltage. Okay, according to this formula, we will have to change the voltage or to change the resistance. So here in this case we will change the resistance. So how to change the resistance? So for that I am going to write another formula which is given by the equation of the resistance. So here is that R is equal to rho L by A, and from here I can write that R is directly proportional to L. If we move this sliding contact away from this knob, the extra wire, the current will pass through this extra length of the wire. So due to which the length of the wire increase, and if the length of the wire increase, the resistance will increase, and here from this relation the current passed through this will decrease, and mean that the current through this resistor will decrease, and this light will glow, and the intensity of this light will decrease. So here we can conclude that through the explanation it looked like confusion, but this is very simple. Here what I am going to say is that if I move this contact from this side toward this side, so here if I move this contact from this side toward this side, so due to which the extra here the extra wire is the current will pass through this extra wire. So here in other words we can say that the length of the wire will increase. So in this case, in this first case, the length of the wire is increased. So this is the first case. In this first case, the length of the wire is increased. So from this relation, L is directly proportional to resistance, we can say that the resistance in this wire will increase. So if the resistance in this wire is increased, due to this relation, the current the current in this wire will be decreased. So R is inversely proportional to current I. So due to which the current is decreased. If the length is increased, the R also increase, and due to which the current is decreased. So here less current will pass through this resistor here, and due to which the intensity of the light in this case will be intensity of the light in this case will be decreased. So this is the first case. Now if I move this sliding contact toward this point, then what will happen? So we are going to discuss that. So here if I move this here, now in this case with respect to the original case here, this is case 2. Now the length is decreased, the length through which this current is passing is decreased. So here the extra length is only this length of the wire. So in this case this length is less. So if this length of the wire through which the current passing is less, due to this relation, the resistance in this wire will be less. And according to this relation, if the resistance is less, the current will be more in that what we can say in that wire. So here the current will increase. So more current will pass through this resistor, through this bulb, due to which the intensity of light of that bulb will be increased. So intensity of that light will be increased. So this light will be more intense. So in other words, we can control the flow of the charges in this we can control the current in this circuit by changing the length of the wires. So if we increase the length of the wire, the current will decrease, and if we decrease the length of the wire, the current will be increased. And we in this way we will take the desired current from the circuit. Now again to here to the first page, as we discussed before that, we here in this case is our desire to increase the speed, increase or decrease this the speed of this fan. So how we will do that? Through this rheostat. As we discussed before that, this rheostat is used to increase or decrease the current. So we will use that functionality of this device, and we will use the speed of this resistor by increasing or decreasing the current to it. So we will rotate the knob of this dimmer, and beside here we will have the rheostat functionality, and by rotating this knob, the sliding contact of that rheostat will be changed, and due to which the current allowed to this resistor will be changed, and in this way this fan will the speed of this fan will be increased or decreased. So this is the practical example of this rheostat as the current divider. Now in this second part of the video, we will discuss that how rheostat is used as a potential divider. So until here in this video, we know that how rheostat is used as a current divider, and it has this application and many more applications as well. So from this position in this video, we will discuss that how rheostat is used as a potential divider. So for that, I select this same rheostat and copy the image from here and put that to here. So this is the same rheostat, and now we will discuss that how this rheostat is used as a potential divider. So for that we will have some the problem statement, and the problem statement in this case is this. We have the problem statement, and the problem statement is this. We have the LED, as we discussed in the start of this video. We have the LED. So this LED required let's say 3 volt battery, 3 voltage, 3 volt. This is 3 volt LED. Okay, this is LED, and here this rheostat is connected with 10. So let's say we have 10 volt battery. We have 10 volt battery. Mostly the batteries are there is no such a small voltage battery provided in the market. So let's say we have this 10 volt battery, a small battery. This is the positive terminal and this is the negative terminal of that battery, and we have this LED which required only 3 volt, and we have 10 volt battery. So what will we do with this battery in order to reduce their voltage to 3 volt in order for this LED? So what we will do here? So we have we need some device between these two, this LED and this battery, in order to reduce this voltage from 10 volt to 3 volt, and that will use by the LED here. So that device, that intermediate device here is that same rheostat. So this device we will use between these two is this rheostat. This rheostat will reduce the voltage from 10 volt to 3 volt, and safely this LED will be on. The positive terminal of this battery is connected to here, to this knob, and the negative terminal of the battery is connected to here. So here the potential difference is 10 volt, and we can say that here the potential is 0, and this is the 10 volt, and the potential here difference here is what we can say here, the potential difference is 10 volt. So similarly, consider this part. Consider this point in which which is connected to a negative terminal of the battery as point B, and this point is I am going to change the color here. So for that I am going to take this black color. So this is actually point A, and this is the point B, and here will be some potential difference. In this case, that potential difference is actually we have this potential difference present between A and B is VAB. So here the potential difference is VAB, is the potential difference between A and B, and which is 10 volt in this case, and the resistance between the point A and B is the RAB. Similarly, the potential difference between this is actually the sliding contact, and which is represented by C. So the potential difference between this C and this point B. So here we have this point B. The potential difference between this C and this point B is given by VCB, and similarly the resistance for that is RCB. So this is the circuit we have, and in this case how to connect. So first we connect this battery to this device, and after the device will perform their functionality, and after that the specific, in this case 3 volt voltage will be provided to this LED. So how to connect this LED with this device? Connect this terminal of the with this contact C. So this terminal of the LED we connected to this contact C, and this terminal of the LED we connect to this point B. So here this is the VCB or VBC. So here the potential difference now passed through this LED is VBC, which is here from point B to point C. In order to we will decrease this potential according to our desire. So this looks like complex, but this is very simple. So here we have this circuit, and this circuit is labeled here as in your book. So this is that same circuit, and this is VBC, and VBC is the output. In this case, the output voltage. In this case, this output we desire, our desired voltage. So this is the same circuit here. Now what is happening here inside, that the 10 volt battery will convert into 3 volt. So let's discuss that. Now in this case, the potential difference, if the sliding contact, consider if the sliding contact is present here at this point, this contact is at this point, then the current, so in this case the potential difference between A and B is 10 volt, and if we move this sliding contact toward this point B, so if we move this C toward this point B, let's say we move that to here, this is the sliding contact. Now the resistance will be this, so this is R CB. RCB will be decreased as compared to that. If the resistance is decreased, then according to the Ohm law, V is equal to IR. In this case, let this RBC, this VBC is directly related to this RBC. So from this relation, if the resistance is decreased, so VBC is directly proportional to RBC. If the resistance is decreased, then the voltage will be decreased here between this contact C and this point B, due to which if the voltage is decreased, so this voltage will decrease from 10 volt to towards 0. So here it may be at this point, that may be 5 volt. So this is the mid between A and B, and if we bring this sliding contact C toward more close toward this point B, let's say that sliding contact B is bring toward here. So if we bring that sliding contact to here, then the RBC, the resistance will decrease here, because the length is decreased between the point B and point C. So here in this case the resistance has decreased. So in this case the resistance RBC has decreased. If this decrease according to this relation, the VBC will also decrease. So the potential difference will decrease from 5 volt, and let's that will be in this point the voltage will be 3 volt. In this in this point the voltage will be 3 volt, because now the distance between this point B and that contact C is less. If the distance the length is less, the length of the wire is wound around this pipe is less, then as L is directly proportional to R, from this formula R is equal to rho L by A. If I move this sliding contact toward this point B, then the length of this wire will be decreases, due to which the resistance is decreased. And if the resistance is decreased, then according to this relationship the potential difference will also decrease, and due to which even let's say in this point this voltage become 3 volt, and when this sliding contact come to here in this point, then this LED will be glow off.